Hello, good morning to all participants. Thank you for joining us today on the day 3 of our online short course on the flood early warning system. As we all know, we have arrived on the day 3 of our online short course, and for today, we already have joining us today our facilitator. Before we start this course, I would like to do a quick introduction to our facilitator today. So for this morning, we already have Mr. Muhammad Fauzi joining us. He is a water resources engineer in the Directorate of Water Resources Engineering Development, the Ministry of Public Works and Housing. In addition, he also holds a major role developing some flood early warning system that has been established in Indonesia, very well established. And for now, Mr. Fauzi is going to talk about FUSE implementation in Indonesia. So without further ado, please welcome Mr. Muhammad Fauzi.
Thank you, Ms. Yosa Aulia. Good morning, everyone. Okay, my name is Fauzi, Muhammad Fauzi. Today we will study sharing about FUSE implementation in Indonesia. This FUSE, but this FUSE especially FUSE that made from Ministry of Public Works that based on Delphius from Netherlands. Today, I'm sorry because I'm on the way to Lampung, and I'm scared if my internet connection will interrupt. I use video for the sharing, but I will continue when we discuss session for today. Please, Miss Yosa, can we start the video? I will continue when we discuss session. Thank you.
Sure, Mr. We're going to start sharing your recording video.
Okay, good morning, everyone. Today I want to explain about the FUSE implementation in Indonesia. But FUSE here is a FUSE made by Ministry of Public Works and hosting this on the FUSE from Netherlands. Maybe some of this system has been mentioned by Professor Walio and from this Delpres yesterday. But for I will introduce myself. My name is Muhammad Fauzi. You can call me Fauzi. I'm a water resource engineering, water infrastructure security subdirectorate in Directorate of Water Resource Engineering Development, Directorate Water Resource in Ministry of Public Works and Housing. If we talk about flood early warning system, and we talk about the purpose of making flood early warning. This one is providing warning to the recipient or information so they can be prepared and take appropriate action according to the condition, situation, and timing to the minimize loss of life and property damage. The second one is flood warning are integral component of disaster management for flood prone community. Say the system provide lead time for evacuation. The longer of the available time, the more time there is for evacuation, resulting in reduced risk of disaster. Okay, the effect of data availability in flood warning system that will greatly affect the speed of analysis to be performed. The faster the prediction data available, the longer the lead time will be available. The longer the available time lead time, the more time can be used for the reducing the risk of disaster. We see it data fit NVP or numerical weather prediction have the fastest available data compared to the satellite data, radar data, or telemetry data. But numerical weather prediction have the lowest accuracy compared to the others, and the telemetry data is the provide the least lead time, but has the greatest accuracy for the prediction of the rainfall data. Okay, early warning system is often measured by the ability to provide sufficient lead time. The longer the lead time, the greater the potential for individual or community to take proactive measures and reduce the greater the potential for individual or community to take the proactive measure to reduce the impact of the impending hazard. As technology and forecasting methods improve, effort focus on extending lead time to enhance disaster preparedness and responses. Okay, maybe yesterday portfolio and Deltares been talk about this. Delphius is a software that created by Deltares, Netherlands, and developed by Cosair through the joint corporation program. Delphius is open source platform that developed for flood forecasting and early warning. Basically, it's a set of sophisticated model designed to build
We are going to continue the stream video.
Today, portfolio and deltas have been talk about this. Delphius is a software that created by Deltares, Netherlands, and developed by COSAIR through the Joint Corporation Program. Delphius is open source platform that developed for flood forecasting and early warning. Basically, it's a set of sophisticated model designed to build hydrological forecasting system tailored to the specific requirement of each organization. Delphius is a software that developed by Deltares that for provide the easy and the modular way for preparing operational forecast system due to the modular approach. Fuse make it possible to connect multiple data source, models, and data type. This can be configured in the Fuse configuration file. Fuse is a comprehensive system designed to monitor, to predict, to provide early warning. It involves a combination of the data collection, the analysis, modeling, and communication component to help mitigate the impact of disaster on communities, infrastructure, and the environment. Main data input for views such as satellite data, real-time telemetry, data ground, terus radar data, and then land use map, soil map, the digital elevation model, and data of rivers and catchment. The data will be imported to views and give some analysis using the model and will produce like wave flow, SOBEC, RTC, real-time control, and rebasim. And because of using the views can using the different model, it will produce the a different application early warning, such as flood forecasting, like GFuse, OCFuse, Fuse kind, Satgas Banjir, and then landsat forecasting, use, and then drought forecasting, and then for the system information about water availability. And okay, the first one we talk about flood early warning system that have been made in Ministry of Public Works based on Delphius. Okay, this is the two type of the flood early warning system. The hydrodynamic one, like Jakarta Fuse, Partitaran Fuse, and Shanghai Fuse, and Semarang Fuse, and based on regency, based on the rainfall data. It we call the flood early warning based on regency or Satgas Banjir. Okay, the first one is Jakarta Fuse or GFuse. GFuse developed at 2011 and 2013 through joint corporation project phase one activity. And 2012 flood management information system FMIS activities were carried out which made a major contribution to the development and participation of each stakeholder. And at 2017 to 2020 in JCP phase 3 improvement were made to Jakarta Fuse. It's take 5 years to improve into the GFuse from the first one at 2013. The concept of GFUs is include several steps such as data collection, data transformation, running models, then analysis, and the last one is action. The basic data such as cross sectional profile, infrastructure data, base map, and then that have been collected and then transferred into the numerical models, specifically using the SOPEC model, and which sort of the foundation for the view system that will be used and for an early warning system. The diffuse model, the hydrodynamic fuse model like GFUs, UGFUs, and etc. Using SOBEC model for calculate for the water level, discharge, and inundation using SOBEC. Jakarta flood model concept is based on hydrodynamic model. Flow calculate in the Jakarta flood model. Flow calculate from rainfall using Sacramento model, using SOBEC rainfall runoff plus Muskingum routing. For the flow propagation in the river, using SOBEC 1D routing, and for the flow routing in Indonesian area, SOBEC using SOBEC 2D dynamic routing. The main difference between 1D one-dimensional and 2D hydrodynamic model lies in a spatial representation and complexity if the water flow and related process they simulate. In 1D hydrodynamic model focus on simulating water flow and associate phenomena along the one direction, typically within a river or a channel. It assumes that water flow primarily occurs in a linear pathway. For 2D hydrodynamic model, a model consider two spatial dimensions, typically representing the horizontal plane, x and y coordinates, and this allow for the simulation of water flow and relate process in both lateral and longitudinal direction. In 2D models are generally more complex and computational demanding than 1D model due to the additional dimension and variable considered. For and 2D model can capture complex flow interaction, floodplain dynamics, and local variation in flow and water level more accurate than 1D models. While 1D are effective for river channel and relatively simple flow scenarios, 2D models are necessary for simulating flooding and in complex terrains and urban areas and coastal zone. It's different. That is different for 1D model and 2D model that used in Jakarta flood model concept. Flood hydrology model in Jakarta had been in Ciliwung Cisadane catchment. This Ciliwung and Cisadane catchment, we make more detail to sub-catchment, and for the Ciliwung Cisadane catchment, we divide the catchment to the 449 sub-catchment to get a detailed result. And then in the Ciliwung Cisadane catchment, it have 22 weirs and have 32 orifices and have 33 pump station. It had this infrastructure had been in Ciliwung Cisadane catchment. This is the picture of the flow schematic that consists the infrastructure like weir, orifice, and pump. Cisadane have 32 output and orifice, and 32 pump and 22 weir. From the shape file and of catchment and the river, then we make a translate to make more detailed schematization that we can see more detail about Ciliwung Cisadane schematic, and from the this schematic we make a schematization in a Sobek model for the flood model. For the in the Sobek model, we must translate the schematic Jakarta flow to schematic model in Sobek that we can run flow model in Sobek model that can be used in Delphius for forecasting the flow, discharge, and maybe inundation area in Ciliwung Cisadane. This is the visualization of the Delphius that consists the hydrodynamic model integration from Sobek. We can see the water level in some river, and then we can see the forecasting and the inundation simulation model, and then we can see the time series analysis for the water level, maybe discharge, or maybe we can see the forecasting of the water level that maybe make some flood event. This is the flood calibration in Jakarta at Delphius. We make water level calibration in Sobek model. We use flood discharge at 2007. Why we use the data 2007? Because in 2007 there is flood event and the data is quite good. For the water level calibration, we're using some observation point like Katulampa, Kebon Jeruk, dan Sawangan, and Paus Depok. This is the flood inundation validation and Jakarta. For the flood inundation validation, we use the data at 2014 using the data from the Pemprov DKI, and we use water level data from Manggarai to validate the model, the Sobek model, to get more good result for the Sobek or for the forecasting for the flood event using Delphius or direct result for the diffuse maybe. This is the flood verification at using 26 April 2019, where from the verification result indicate prediction of the water level at several observation points that we can see in the red line. This is the prediction of the water level that can be occurred in several observation points. And we can see at Manggarai, the water level having to the position of the siaga 1, it can be make cure in this picture is bulletin of GPUs. The views make bulletin for the result of the model. Bulletin GPUs can be accessed on the internet in the link in bulletin /gpus.usair/pu.go.id. This is can be accessed on internet. In GPUs use for the bulletin, it gives some information. It exclamation point to give the flood information. The observation was like Tolampa, Manggarai, Aki Hulu, Kulukut Hulu, Pinang Hulu, Karet, Pulau Gaudung, Sangran, and Suntoro. This is the observation post that we can see at bulletin GPUs in internet. In bulletin GPUs, we can see the real-time water level, and in observation, and we can see the forecasting of the water level at for 2 days in observation point. The next one is for the user views. For the user views and Sanggai views and Semarang views, they have the same process like GPUs model, like using the model data, using the schematization in Sobek, using 1D model, 2D model for the inundation. It's the same process like GPUs data, but in different area. Like user views, this using the information in architectural views, and they call UC views, and then this views using the GPUs using the observation post that can give the information about water level and forecasting water level. In user views using 6 observation posts is Nanyung dari Kuala Selatan, Sulawesi Jeruk, Majalaya, dan Pemasan. This is for the Sanggai views. Maybe this is not complete because it's in Sanggai there's not observation post that installed in the river. Then this is just the water level it can get from the Sobek model. This is just the water level from the Sobek model. Why we choose the Sanggai catchment for the flood? Because Sanggai catchment, because the new capital city of Indonesia will be located in Sanggai catchment. That's why we choose the Sanggai catchment to make to make the flood early warning system. And the last one is the Semarang views. Same like Shanghai views, it's not complete, but in Semarang they have installed observation posts, but we have not been linked the observation post to the views. We can see from the view Semarang they have 5 posts, observation posts like Bendung Barang, Cismoko, Gemah, Gading, and Simongan. Okay, this is the first one for the hydrodynamic views using Sobek model base for the flood early warning system, and we move to the flood early warning based on recurrency, or we call gas banjir. The purpose of gas banjir is to able to provide flood early warning information in each recurrency for next 2 days. And scope of gas banjir is early warning system based on regular rainfall, where the scope of the system are all district in Indonesia. Okay, the main input of the Satgas banjir are flood hazard map and vulnerability for each district and district map, and then using the observation rainfall data and satellite rainfall data, and then using rainfall prediction model using ECMWF from district map and flood hazard map and vulnerability map. Then it classified to the 3 classes, such as high flood potential area, moderate flood potential area, and then we have safe zone or the low flood potential area. From 3 classes of the flood potential area, if we combine to the UC with observation rainfall and satellite rainfall, and we use using rainfall prediction model, we can get the 3 criteria of the prone area. Yeah, such as the criteria is the green one is the tidak rawan banjir or not prone to flooding or safe zone, and then the yellow one is called rawan banjir or prone flooding, and then the red one is sangat rawan banjir or the very prone to flooding. It is comparison of observation rainfall and satellite rainfall that will be used in Satgas banjir. We use 3 satellite rainfall using GS map, GPM, and CMOP data. At SBC, GPM give more correlation compared to the GS map or the CMOP. This because the correlation, the GPM has give more best correlation compared to the 2-1, and for the warning accurate with the flow event, GPM give more accurate information depending the GS map and CMOP data. But if we use the combination of the 3, we can get more accurate information warning. The meaning of the combination is the system will automatically choose the highest data from GS map, GPM, and CMOP, and give the information when the highest one, and then will give more accurate information warning, flood warning. It depends. We use just one slide data. The correlation of the daily rainfall and 3 days rainfall to the flood event that occur on 2021 and 2022 at in various districts. We get the limit of the daily rainfall and the 3 days rainfall that can trigger the flood in various districts. The daily rainfall limit from 30 millimeter to 280 millimeters, and 3 days rainfall from 50 millimeter to 430 millimeters. The information of flood potential on each district information are distributed using social media. In social media that we use is WhatsApp group. In this WhatsApp group, the personnel consists of the stakeholder from the BNPB. This is a national agency for disaster management, and then from BNPB, National Agency for Geophysics, Climatology, and Meteorology, and then in Ministry of Public Works, and from stakeholder from province. This information have been distributed daily at morning and at the night, twice day, or the distributed of information. Okay, I think this last slide for the flood early warning system that is dynamic and based on rainfall, which we call circus band here. But because views using a lot of models, views can be modified to another early warning system. In Ministry of Public Works and Housing, it had 3 modified or 4 views. Like the first one is for the landslide. We call it landslide early warning system, LEWS, and then system water availability index, or SIWAMI, and then the last one is the sistem informasi kekeringan or drought information system. Okay, the first one is landslide early warning system, or the early resistance for the landslide. The background of the leaves is to trigger for the sediment disaster, such as flood and landslide in general influence. Then hydrometeorological disaster mitigation can be done by knowing the relationship between amount of rain intensity and the occurrence of disaster. And then leaders need system but the right decision or policy when disaster occurs. Okay, why we need to use? Use is developed because the leader need real-time information about landslide warning that fast and easy access and reliable and key information provided for 3 days. This is why we need news or to get fast information, and we can get the information, the forecasting for 3 days. News built on 2017, and this is the modification from FUSE, from flood early warning system. Input data for the news is just 3. This is using landside vulnerability map from BNPB, the volcanology agency, and using the real-time rainfall, using this views, just using GPM data, and then using the rainfall prediction data using ECMWF from GMKG. This is the same like the Satgas Banjir, and maybe same like the stroke is just using real-time rainfall GPM and rainfall prediction using ECMWF. And the process for use is use just rain-based landslide. The landslide triggering the rain threshold based on the data trigger rain following each landslide event using cumulative rain 3 days rainfall or using cumulative daily rainfall. Prediction of landslide prone location only in landslide prone areas from the land movement prone maps from PVNBG, and very prone to landslide when the daily and 3 days rainfall limit the threshold. The landslide will occur if the daily and 3 daily rainfall limits it pass the threshold. Prone to landslide if only the daily limit is passed or only the 3 daily limit pass. The landslide is only if the daily limit is passed or only the 3 daily limit passes. Just 2 conditions: daily limit is passed or 3 daily limit pass. It's of the display of results from views, which indicates the area with an increased possibility of landslide due to the rainfall. The information can be accessed in internet as same like and distribution same like the services on WhatsApp group. The group is same like Satgas Banjir. One the challenge for development of views. The first one is rainfall threshold for certain areas, and find first method to make a specific threshold for small and detailed area, because each area has different parameters that affect how lands occur. And the second one is integration with the other modeling framework or like maybe for landscape is called triggers modeling, and if with more detailed result, like GPUs, they using Sobek to get more detailed flood early warning system depend compared to the Satgas Banjir. Maybe if we use using the model for the landslide, like tricks, we can get more detail because Leos today just using rainfall threshold, rainfall threshold for give the early warning system. Okay, we move to the second one. We call SIWAMI, System Informasi Water Availability Main Index System Informasi Main Information System in Indonesian language. SIWAMI is mixed with Indonesian language and English. System Informasi Water Availability Main Index. The SIWAMI objective is to calculate Q80 at every point of the river with information of Q80, maybe Q90. We can know how the water availability in the river and in the catchment. The data that in use for SIWAMI divide two types, is dynamic data and static data. The dynamic data consists of the satellite data like TRMM or GPM, potential evaporation using CGI AR, and data ground. For the static data using NEMIS map, soil map, soil classification, digital elevation model, and the data of the river and the catchment. The data, the dynamic data and the static data is using as main input for the waveflow model to calculate the water availability in each river. The topography model that we use for the generate of the river and the catchment using digital elevation model, is using SRTM 90 meters, and then rivers and catchment using hydroseeds under constant local improvement where necessary, and land use using data from Geospatial Information Agency, and soil type using FAO soil type. The input data for the satellite data using for the SIWAMI using TRMM data. The TRMM data has been corrected by Ronald van Linden in 2012 using several observation point in Sumatra, Java, and in Kalimantan. In Sumatra, using the observation point in Lampung. In Java, using observation point in Jakarta, Bogor, Bandung, and East Java. And then in Kalimantan, using observation point at Banjarbaru. Okay, this is the topographical input that using a SIWAMI using SRTM digital model 90 meters. Then the land use classification using the data from BIG or Geospatial Information Agency that have 9 class for the land use, like bare area, grassland, scrubland, rice field, crops, plantation, forest, and water bodies. This is the simplified one for the land use classification in BIG. Then we use the soil data from FAO, digital soil map of the world. This is the digital data for the soil that it consists in all of the work that we use for the Indonesian soil classification. Okay, this I think it's I have talked about it about input data from Webflow is using correct data memo, potential evaporation data from CER, and discharge data for calibration, and that's static using the map, soil map, and land use map. Webflow, Webflow using a hydrological model concept. Webflow is a three-dimensional topographical and physical model concept are related to topographical features, elevation, slope, river network, and land use and soil type. Even uncalibrated model, Webflow provide realistic result as long as natural flow. The meaning of the natural flow is the flow that has not been affected in by man-made infrastructure like reservoir, weirs, or main intakes. That the wave flow can give realistic result. It is just natural flow, not had been affected by man-made infrastructure. People technological model can get stats whenever you pick the location, as long as it can get the discharge data, and you can get the time series data of the discharge from the all of the point, as long as it in risk flow. The Webflow model has been invalidated and transition in Java, Sumatra, Kalimantan, and Sulawesi. It is using several observation, not just one observation in one island, but in one island using several observation point to validate the data. But we choose the observation point that in the observation there's not man-made affected river. This is the implementation of the Sulawesi. Like we can see the river from the DM that we can pick the anywhere in the river at the Sulawesi, and we can get the data, discharge data, the time series discharge data in several point, or the anywhere we can take the point as long as it's in the river. Okay, The last one for the system information is the system informasi kekeringan, or we call the drought information system. This is an example of drought information system for Mahakam catchment. This system is still just a prototype because it's not complete and not distributed yet. The information that produced by sistem informasi kekeringan Mahakam catchment, like weather data, is historic potential evaporation, near real time, and prediction. Satellite rainfall data, like GFMAP for the historic and near real time, and then prediction rainfall data, ICMWF. This data just are input for the model data, and we can get the waveflow model, the historical distance of the Mahakam river, and near real-time discharge, and the prediction of each bit, same like the tsunami. And in system function, we get information about meteorological drought index, or SPI, hydrology drought index, or SRI. This is the weather data, weather information, and that we can get in the system information kekeringan, or drought information system, drought information system. In drought information system, we can get the near real time potential evaporation, gas map, satellite rainfall data, and then we can get the potential evaporation prediction, and then we can get the rainfall data prediction from BNPB. In like I talked before, the drought information system based on the waveflow model, that we can see the historical discharge from the river. We can select the location, and we can get the historical discharge based on rainfall runoff using using GSM data. And this is the waveflow model for prediction discharge based on using the data for the CMWF to get the prediction discharge for using waveflow model. In tsunami, we cannot get the prediction discharge, but we can get the calculate the historic discharge within the information system. We can get the prediction discharge using the rainfall prediction SCMWF, and this is the result of the calculate for the historical SPI for the meteorological drought index. This is the prediction of SPI from the prediction of the meteorological drought index, and this is the historical hydrology drought index, or SRI, and this is using the calculated using this chart from waveflow model. Okay, I think is this the last slide of my presentation. Thank you for all your attention. I'm sorry if I have a lot of mistake when in my presentation. I hope this sharing can give more information about flood early warning system in Indonesia, especially flood early warning system based on self views. But okay, I think I have a little bit assignment for all of you. Okay, this is my assignment. Please do this assignment and upload it in IMS, and I will check the results of all of you. Thank you. Maybe you can screenshot this assignment. You can do later and can upload it in IMS. Okay. Okay, I think it's enough for this presentation. Good morning. Thank you for all your attention. Thank you.
Thank you so much for the presentation, Mr. Fauzi. Is there anything you would like to add?
Thank you, Yosa. My sound is clear or not? Check. My voice is clear or?
Yes, we can hear it clearly,
Okay.
Mr. Fauzi.
Thank you. Before I think discussion session, I have a quiz for all of you. Maybe we can start the quiz using quizzes. I think. Please.
Mr. Fauzi, I'm sorry. Will the quiz will use Kahoot or quizzes?
Quizzes. Maybe
Quizzes.
quizzes, because
Okay.
my Kahoot is free account. I think it's just 40 member. Because this in this online course, I think more 40. I think uses quizzes.
Okay. So for all participants, please wait. We will share the link on the chat box. The link is already shared on the chat box. All participants can now click on the link. To all participants, I remind you again that the link is already shared on the chat box. And right now you can click on the link and also join the quiz. Today we have around 30 participants on the Zoom. So we will wait until it reach nearly 30 people before we start the quiz. For those who haven't joined the quiz, I encourage you to click on the link and join the quiz. This is the quiz that has been prepared from Mr. Fauzi. Because no one is joining this quiz room. So I think we can start, Mr. Fauzi, with 28 participants.
Please, you can hurry because there's no one joining.
Okay, get ready to all participants. We will start in 3, 2, 2, 1. while we wait for other participants to finish the test, perhaps we can start the discussion session before maybe Mr. Fauzi having issues with the signals up there. So for the participants, if you have any questions, you can virtually raise your hand.
Or you can write in the chat box. I think great.
Yes, you can also leave your questions on the chat box and we will read it. So all participants, if you have any questions or do you want to hear more detailed explanations on the FUSE implementation in Indonesia, you can ask directly to Mr. Fauzi while we still have him here today with us, or you can drop your questions in the chat box. And for Indonesian participants, don't worry if you want to ask your questions in Bahasa Indonesia. We will translate it later for others. Mr. Fauzi, regarding the assignment that you've assigned to the participants, is there any deadline for the submissions of the assignment?
I think I follow the deadline from the first jam, maybe.
Okay.
I think I can visit for maybe Saturday or Friday tomorrow maybe.
Okay, so the deadline will be tomorrow.
Yes, because I think it's the assignment. I think it's easy, and maybe tomorrow it's deadline for the assignment.
Okay, after discussion, the deadline will be set at tomorrow for the assignment at 9 a.m. in Indonesian time, GMT 7+7. So, Mr. Fauzi, we have all participants here finishing the quiz, and
I think
it reaches 80% of class accuracy.
I think it's a good result because 80% can answer the quiz right answer. Is for discussion. There's any question? If there's not any question, or maybe you can ask later. I add my email. You can just ask me in email or in chat room. Maybe you can ask me later if if you can you have any question later.
Okay, all participants, we still have some times if you have any questions to Mr. Fauzi. Or perhaps, Mr. Fauzi, is there anything you want to explain more in detail about the quiz that you shared to the participants? Maybe you want to discuss it a little bit more?
Chris, maybe okay. I think we um, okay. We discuss about the quiz maybe for take the time. I think I can share. Okay. Okay, this is the question. I did it using Kahoot. Okay, for the first question is purpose of flood early warning system. The accept maybe cross the purpose of the flood early warning system is you give the flood warning, and number two is providing warning, like the first one to receive information and provide lead time for the evacuation. This is the purpose of the flood warning is to give more time to people take the evacuation. And four is the possibility that it's not the purpose of the flood early warning. This is question number one. Question number two is lead time refers to the period between when an early warning is issued and when the emergency event will occur. Is of true. This is the true sentence because the lead time is the period between when you give the early warning and when the hazard is occurred. And because the lead time to give the people time to take the evacuation or to take to go to the safe zone. Number two. Number three, it shorter lead time allows to more effective planning and the response. What is false sentence? Because longer lead time give more effective planning. More time means more effective, more good response from the stakeholders, and give more time for the people to take evacuation or to go to the safe zone. Okay. Okay, number 4, the connection between early warning and the lead time can be understood as follows, except is a preventive measure because the early warning and the lead time give the preventive measure. And number 2 is data collection. This is not the connection between the early warning because the data collection is for just the model, not for the connection about the early warning and the lead time. And number 3 is reduce risk and impact. The lead time, yes, the lead time because the early warning give more the lead time and give more time to reduce risk and impact. And for the number 4 is the decision making for the stakeholder to make right decision, to make good decision for to prevent the impact of the disaster. Number 5, how much sub-catchment derived from the Ciliwung Cisadane catchment? I think it's on the PPT. This is 449 sub-catchment in Ciliwung Cisadane because in Jakarta is in Ciliwung Cisadane have have 449 sub-catchment derived of one catchment.
Mr. Fauzi, I'm sorry
Mhm.
for interrupting, but we
Yes.
have one question here in the chat box. Perhaps while we still have you here loud and clear, we can you can probably answer it first. There's a question from Mr. Said Hazinul. How can we assess?
Okay.
Yeah, do you want to
Yes.
answer it first?
Yes. Okay. Number 1 is how can we access and get the forecasting information data such as ICMWF forecasting data? Is it free for the public? I think this ICMWF is not free. I think because we get the data directly from BMKG, from the Geophysics and Climate and Meteorological Agency. So the data, I think that's not in internet or not in internet, and we cannot access the data because we get the from for the JFUs, for the UCFUs, or for the Satgas is directly from the BMKG. And number 2, what is the main challenge in operation the fuse platform like JFUs? How do you manage the challenge? The challenge may be for the challenge for the operating in fuse because the fuse like JFuse is now is automatically operate, and for the challenge is how to keep the JFuse is up to date. Maybe it's the challenge for the fuse because like Jakarta or like you see Upper Citarum, and every year there is man-made infrastructure like maybe weirs, maybe reservoir, but in the model we cannot update the data every year because the data is not we get every year, but we we will try to update maybe 2 years, every 2 years, the model to get update, up to date the model for JFU or JFU. Maybe, and the second challenge maybe the data collection for the observation data. The data is correct frequently because the telemetry maybe can send the data to the server and we can get the real-time data, and because there's not real-time data, of course, the prediction data cannot the right prediction, because the prediction data depend on real-time data for the correction, I think. But I think it's a challenge, like from geos or views or fields else. I think. There's any question again?
Okay, thank you, Mr. Fauzi, for the explanation, and thank you, Mr. Said, for the questions. We still have time for discussion. So for all the participants, if you still have a questions, you can ask in here. But in the meantime, perhaps Mr. Fauzi, if you would like to continue your explanations on the quiz.
We will continue with quiz. Which one is on dynamic data? The
Sir Fauzi, I'm sorry, your voice is quite unclear.
Okay, good.
I think
Check.
we are losing you in here. Maybe slowly your signal is weakened. Okay, unfortunately, Mr. Fauzi's signal is not cooperating with us. So for all participants, if you still have any questions, you can email Mr. Fauzi. He already dropped the email on the chat box. Or later, we will create a forum discussion on the LMS, and you can drop your questions, not only questions, perhaps if you have some comments or some topic you would like to discuss with other participants, you can also drop it on the LMS. And I want to remind you again of the assignment that Mr. Fauzi shared before. You can do your assignment and then later upload it on the LMS. The assignment deadline is tomorrow at 9 a.m. of Western Indonesian time. And also today, later on today, Sorry, I see a raised hand in here, Mr. Ade. Is there anything you would like to say to the forum in here?
Okay, thank you. I want to ask something to Mr. Falsi.
Mr. Ade, unfortunately, we already don't have Mr. Fauzi with us for now because I think he's having some issues with his signal. He's actually on his way to Lampung.
Okay, so I will drop the question on the chat box.
You can drop your questions on the LMS, or other way, you can email him directly. He already shared his email on the chat box.
Oh, okay. Thank you.
Yeah, I'm so sorry. Also today, later, we have post tests. And I encourage to all of the participants, if you haven't filled or you haven't done the pre-test, you can still do your pre-test before doing the post-test. And for all of the participants that have already succeeded in filling or in doing the pre-test, you can go directly into the post-test later. Unfortunately, Mr. Fauzi will not be able to join us again. But I believe that the presentations is well explained, even though it's in recording. And I believe that the participants still managed to learn about fuse implementation in Indonesia. I'm certain that Mr. Fauzi actually really wants to deliver the material directly to all of you. Thank you so much for the presentation to Mr. Fauzi, and thank you also for all the participants for all of your enthusiasm on today's session. And for now, we will start our post test. To all of the participants, you can go directly into the LMS link. For those who haven't finished the pretest, there is still time for you to finish the pretest. And for those who have finished the pretest, you can go directly to the post-test. So up until now, we have 2 assignments. that's been assigned. The first assignment was assigned by Professor Waluyo, and the second was assigned by Mr. Fauzi.
Ibu kalau yang rapat berat ini sama Ibu udah disampaikan mengingatkan.
When you finish your assignment, you can upload it on the LMS. The first assignment from Mr. Waluyo, you can upload it on the August 22 topic. And for the assignment that's been assigned by Mr. Fauzi, you can upload it on the August 24th topic.
Ngingetin aja.
So all participants, I believe we have come to our last session today, the post-test session. While you all finishing your post-test, I have some announcement to make. So tomorrow, we will start our session at 1:30 p.m. in Indonesia Western Time. And also tomorrow we have a seminar and wrap-up discussions. We expected your active participations for tomorrow, and we will select some participants to be presenting your assignment tomorrow, and the discussion will be led by Professor Waluyo. So the material that is going to be discussed tomorrow and will be presented to the selected participants will be the assignments from Professor Waluyo. And we are going to announce the selected participants who will present by tomorrow. So we encourage to all of you who haven't submitted your assignment to submit it soon, as we will select the participants from your assignments that's been submitted on the LMS. Ya, tanya. And we would like to remind you of certificate completion. So the certificate will be issued for participants who accomplish the mandatory activities, which are you have finished your pre-test and post-test, and then you submitted your assignment. There are 2 assignments in this online course. And then you access learning videos. It is for all the participants that that are absent. And then next, for participants who have completed the evaluation form and later the evaluation form will be uploaded on the LMS, we will get back to you if the evaluation form is already uploaded. And then last, it will be issued for participants who filled out the attendance form that we have shared every day.
Yang evaluation form itu kata Bu Dona, minta Bu Rora aja Bu. Karena beliau nggak ini.
So I think that concludes our session today, but we still have this Zoom room open in case you have any questions regarding the post-test or the pre-test. We will see you tomorrow at our next session, once again at 1:30 p.m. in Indonesian Western Time. Good luck on the test and see you tomorrow.
Maybe when we meet for office then. Huh?
You can freely leave this Zoom and continue your post-test without joining the Zoom. But we will be here if you have any questions. We will have this room open until 11 a.m. in Indonesian Western Time. Nggak, aku bilang aja. Hello, all participants. We will be closing this Zoom meeting in 5 minutes. See you tomorrow at tomorrow's session at 1:30 p.m. in Indonesian Western Time. Thank you and have a good day.